Okay, so dear cadets, in video number 1 we saw how to draw the magnitude plot of the given function. Video number 2 we saw how to write down something called as the phase equation. So this was the phase equation. So we saw in video number 2 how to write down the phase equation, and then we have to plot the magnitude curve and the phase curve one below another. Okay, so this was the magnitude curve, this was the resultant, and this was the phase curve. So from here we have to find out something called as 4 things we have to find out. Something called as gain crossover frequency, phase crossover frequency, gain margin, phase margin, and we have to comment on the stability of the system. Okay. So as you are aware that gain crossover frequency is that frequency where the magnitude curve cuts at omega is equal to 1. So this becomes my gain crossover frequency. Similarly, when the phase curve cuts 180 degrees, that becomes my omega PC. So this was omega GC and this was omega PC, right? So the omega PC is roughly, now this is 1 radian per second, this is 10 radian per second, so it will be somewhere around 3 point something, right? So omega GC, gain crossover frequency, is 1 radian per second, phase crossover frequency is around 3 radian per second, right? Now at this frequency I am going to have the gain crossover, and this is the margin available with me. So this indicates something called as the phase margin. Now this is 180 degrees line. Okay, now this angle is somewhere, now this is 120, this 30 degrees has been divided in 5 equal parts. So this will be 126, 132, 134, right? So 134 minus 180, so this will be around 40 degrees. So that is my phase margin. Similarly, where the phase curve cuts minus 180 degrees, from there I have to see how much is the margin available with me, and that will be called as a gain margin. Okay, so this is around minus 20, right? So had this been above this, the gain would have been positive and the system might have gone into might have become unstable. Similarly, had this been down over there, so that means the phase margin would have been positive, then the system would have been unstable. So because the gain margin is positive 40 degrees and phase margin is positive 40 degrees and the gain margin is also positive 20 dB, so therefore we can say the system is a stable system. So we found out 4 things. Number 1 was gain crossover frequency, 1 radian. Number 2 was phase crossover frequency, which is around 3 radian per second. Number 3, phase margin. So this is the phase margin. So from gain crossover frequency we find out gain margin, and from phase crossover frequency we found out something called as gain margin, right? So this is phase margin, this is gain margin, and because these 2 margins are positive, we say that the system is a stable system. Thank you.